Good morning, class. You are welcome to the physics class. We are still continuing with equilibrium of forces. Today we want to talk about cosine and sine rule, because we need this rule to solve some problems under the equilibrium of forces. So please listen carefully. I know that you have done this in mathematics, so you have gotten the prerequisite knowledge you need for you to solve this problem. So the topic still remains equilibrium of forces. Equilibrium of forces continued. But today we are talking about cosine and sine rules. Cosine and sine rules. Using these rules to solve some mathematical problems in under equilibrium of forces. So, what is cosine rule and what does it say? Let's state the rule first, so that it will guide you in applying it. The rule states that the square of the length of the third side of a triangle is equal to the sum of squares of the length of further two sides minus twice the product of the length of those two sides and cosine of the angle between them. That's the statement of the rule. Let me tell you that in physics, you will not be asked to state the rule. You will only be expected to know how to apply it. What does it mean? It means that for any triangle with sides of length A, capital A, B, and C, and the angle opposite side C being the small letter C, that of B be the small letter B, and that of A be the small letter A, we can state the rule like this. The cosine rule mathematically can be stated as C squared equals A squared plus B squared minus 2AB cos C. Cos C, the cos of the angle C. So let me have a diagram to illustrate what I'm saying. This is a triangle of forces. Let's say this is A, this is B, and this is C. The side opposite A represented by letter A, the side opposite B, small letter B, while the side opposite C is represented by small letter C. And the angle, look at this angle, this is angle C. So that is, the rule is say, look at it, the C square, that is small letter C rather, this C square equals A square, rather let me use small letter please, is B squared, A square plus B square minus 2AB, then the cos of the angle, cos C. That is the rule. See, understanding this rule will seriously help us to solve some of these problems. Then let's go to sine rule. What does it say? It says the ratio of the length of any side of a triangle to the side of the angle opposite it is constant for all the three sides and the angle of the triangle. As I stated earlier, you will not be expected to state this rule, but only the application of the rule. So let's say use the same triangle. Now sine rule. So mathematically, we can say that as this says that A over sine A equals B over sine B equals C over sine C. By the time we are solving the problem, all these A, B, and C, they will be in form of forces. So they are not really what we used to see in mathematics. So take note, when calculating the moment of a force, that is for cosine rule, it is necessary to calculate the perpendicular distance from the pivot to the line of action of the force. The cosine rule helps to calculate the distance, especially when the force is applied at an angle. Take note of that. It helps to calculate the distance, especially when the force is applied at an angle. For the sine rule, the rule is useful when there is a need to find the magnitude of the force or its components. By applying the sine rule, the force can be resolved into its horizontal and vertical components, making it easier to calculate the moment. So please take note of that. So let's have an example of that. Let's give a problem where we are going to use both the rules so that you can know how to use it. So let's see an example to see. Let's have this figure. Let me draw a diagram to illustrate that so that you can see. This is a force of 10 Newton here. This is a force of another 10 Newton here. The forces, know that forces are vectors, so please always represent them with arrows. Very, very important. So let's say this is the resultant force. Force E is here. It's a force E, and this is a force R. Then this angle is 120 degrees, while this angle is alpha. So what are we to calculate? We are to calculate the magnitude of R and the angle that is with which it is inclined to the force of 10 Newton. So let's do that. So we draw the diagram. This is the resultant is R. You can see that we can the one of the sides is 10 Newton. Another side is also 10 Newton. Applying with this diagram, let's apply the cosine rule. Applying cosine rule, we have R squared equals 10 squared plus another 10 squared, that is the two sides, minus 2ab minus 2 times 10 times 10 cos R. The cos is 120. The cos of the angle between the resultant and one of the 10 Newton forces. So when we do this, let's continue. This is 100 plus 100 minus 200 cos 120 degree. Add this is 200 minus 200 times cos 120. That's 0.5. Then this becomes 200 minus 100. Then we have, we are talking about R squared. 200 minus 100, that is 100. That is R squared. Then the resultant R, we take the square root of 100, and that is 10 Newton. So the resultant of the two forces is also the 10 Newton. Now, to calculate the angle of inclination, with which that is when we now apply the sine rule. So let's go for sine rule. So we can say that is A over sine A equals B over sine. All these ones, we can say, look at one side, 10. 10 over the sine alpha is the angle enclosed between the alpha, then equals R over, this angle is 120. So since the total is 180, so this angle will be 60 over sine 60 degree, then equals 10, one of the side also over sine 60 degree. You can pick any two from the two because since they are all equal, you can say 10 over sine alpha equals, because these two are known, you can say, and also we have calculated the value of R, so it's also 10 over sine 60 degree. I think we are following. So you can see, you cross multiply, 10 sine theta, 10 sine alpha rather equals 10 sine 60 degree. From here you can calculate sine alpha equals 10 sine 60 degree divided by that is r rather r sine 60 degree equals 10 sine 60 divided by sine 60 degree. So alpha is equal to sine inverse of that, and that is 60 degree. So the resultant force is 10 Newton at 60 degree with each of the forces. So the equivalent force is so take note of that. So you can see that I've applied the two rules to solve the problem. So take note of that. Then let's go to triangle of forces. You know, this area is completely mathematics. You need to be good in some degree of further maths. I think everybody is solving further maths in this class. So if you don't offer further maths, then you have to take maybe you go and take an online class for 2 days. Or you look for a friend to teach you something about further maths. So that example 2, a mass of 2 kg is supported by 2 cords which make angles of 30 degree and 50 degree with the vertical. Calculate the tensions in the 2 cords. Look at it. A mass of 2 kg. Mass equals 2 kg. You will convert this one to force. What is force in there? Force is mg. M times g. G is gravity, which to give it a round for used to be 10, so it should be 2 times 10. So the force is 20 Newton. The force is 20 Newton. So we are told that it is supported by 2 cords, each of them making an angle of 30 degree and 50 degree with the vertical. Calculate the tensions in there. So let's have a grammatical representation of what is being said. This is it. This is a force of 20 Newton. You know, we have converted it into a force. It was a mass of 2 kg. So it becomes like this. Then this is a triangle of force. Look at it as formed a triangle already. This is it. Then this is an angle of 30 degree. Then this angle is 50 degree. And this one is unknown. So we can solve it in 2 ways. We can use graphical method and we can use analytical method. So for the purpose of this class today, we are going to use analytical method. So I will advise that you go and use a graphical method to solve the same problem, so that you will know that you will get the same answer. Either you use graphical method or analytical method. In this case, let's now go to sine rule. You see sine rule? So you can see from here, let's say the force is P. We now have P over sine 50 degree equals Q over sine 30 degree equals 20 over sine C. Sine C. So this is C. So take note of that. So we can now continue. Take one of them. So P sine P sine 80 P sine. From here, make P the subject of the formula. We now have P equals 20 sine 50 degree divided by sine 30. By the time you do the calculation, at the end of the day, you will get 10.15 Newton. So that is what you are going to get. Please, I will advise that use graphical method to make sure that you get the same answer as this. So this lesson today is completely mathematics, so we are not going to talk any story here. So take note of that. Let me ask some questions on this to test your understanding. So question number 1, maybe write it down, because it's this one just for you can respond immediately. 3 forces act on an object, produce a moment about a pivot. The forces and their angles are F1 20 Newton at 30 degree, F2 equals 30 Newton at 60 degree, and F3 equals 40 Newton at 90 degree. Which rule will you use to determine the resultant moment? Which rule will you use to determine the... Yes? No? You are wrong? You here? Yes. Yes, thank you very much. There is nothing like triangle. There is nothing like a time rule. Did I mention time rule? Yeah. I said sine rule or cosine rule. So take note of that. That is it. Then a moment acts on an object, causing it to rotate. The moment is related to the force F. It's related to the force F and the distance of D from the pivot. By which equation will you use to relate the force F and the distance D? Just look at it. Just use up to do it quickly. Just mathematical. What we expect you to see? That moment M equals what? What type of relationship will you? Is it FD sin theta? Is it FD cos theta? Is it FD over sin theta? Is it FD divided by cos theta? So you know it causes the object to rotate. So which one? Try to find out. Very, very important. I have further questions for you. Completely mathematical. Write it down. The moment of 100 Newton acts on an object, causing it to rotate. If the distance from the pivot is 2 meters, what is the magnitude of the force? What is the magnitude of the force? And the last one here, very important. A moment of 150 Newton meter acts on an object, causing it to rotate. If the force acts at an angle of 45 degrees to the horizontal, what is the magnitude of the force? So make sure you solve the problem, and then let me have your answer by next class. Okay, that's good. Keep on reading, keep on learning. Learning is a continuous exercise. Thank you. Have a nice day.